Somewhere out past Neptune, two worlds that have almost nothing in common just turned out to be hiding the exact same secret. One is a frozen, nearly airless dwarf planet 4 times farther from the Sun than Saturn. The other is a moon with rivers, rain, and lakes wrapped in an atmosphere thicker than Earth's. They are different sizes, different temperatures, different chemistries, different everything. And yet, when scientists pointed the James Webb Space Telescope at both of them and looked closely at the light bouncing off their surfaces, they found the exact same gap, the exact same missing wavelength on both worlds. A signature that, according to the scientists who found it, does not match a single known molecule anywhere in the solar system or anywhere else we've ever looked. Nobody knows what it is. And the fact that it's showing up in the same place on two worlds that shouldn't have anything to do with each other is what's making planetary scientists sit up and pay attention. I am your name, and this is your channel. If unexplained space mysteries are what you come here for, subscribe now, because this one's still unfolding. Let's start with how scientists actually find something like this in the first place. Every chemical compound in the universe absorbs light at very specific wavelengths, its own unique fingerprint. When astronomers study a distant world, they don't fly a probe down to scoop up a sample most of the time. Instead, they look at the light reflecting off its surface or passing through its atmosphere, and they search for tiny dark gaps in that light, spots where a specific wavelength has been absorbed by something. If you know the fingerprint, you know the chemical. Molecular oxygen absorbs light at a certain wavelength, water absorbs at another, carbon dioxide at another. Compare enough known fingerprints against what you're seeing, and you can figure out what a world is made of without ever touching it. This is exactly how James Webb has identified atmospheric gases on exoplanets trillions of miles away, mapped chemistry in the clouds of newborn stars, and studied objects far outside our own solar system. It's one of the most powerful tools we have for reading the universe from a distance. So, in a new study, a team led by Dr. Bruno Bézard at the Paris Observatory did something relatively simple in concept. They went back through Webb's observations of Pluto and Titan and focused on a part of the infrared spectrum that hadn't gotten much attention before. Very specific, narrow wavelengths that earlier studies had mostly skipped over. And there it was, a distinct, unmistakable gap in the light, centered at almost exactly 511 micrometers. Not once, not on one world, on both. Here's where it gets strange. The team went back through every published study they could find on planetary spectra. Pluto, Titan, other moons, other planets, exoplanets, anything with a documented chemical fingerprint, trying to match this. Gap to something known. They found nothing. No published band, no known molecule, lines up with what they were seeing. Whatever is absorbing light at 511 micrometers on these two worlds has never been formally identified anywhere in the solar system or beyond. Now, before this starts to sound like science fiction, it's worth being clear about something. An unidentified absorption line by itself isn't unusual. Spectra are messy. Scientists find unexplained gaps in planetary data fairly often, and most of them eventually get traced back to a known substance once the right laboratory comparison gets done. That part alone wouldn't make headlines. What makes this particular case genuinely strange is the coincidence. Pluto and Titan are about as different as two solid worlds in our solar system can get. Titan is Saturn's largest moon, bigger than the planet Mercury, wrapped in a thick nitrogen-methane atmosphere with a surface pressure about 50 times greater than Earth's. It has weather. It has rain, not water rain, but liquid methane rain falling from methane clouds, filling actual rivers, lakes, and seas of liquid hydrocarbons on its surface. It's the only place in the solar system besides Earth known to have stable liquid on its surface. Pluto, meanwhile, is a frozen, distant dwarf planet roughly half Titan size, sitting about 4 times farther from the Sun than Saturn. Its atmosphere is thin, mostly nitrogen, and nowhere near thick enough to support weather like Titan's. Its surface is a frozen mix of nitrogen, methane, and carbon monoxide ices. There is genuinely very little reason these two worlds should share an identical chemical signature that doesn't exist anywhere else we've looked. But they do, with one interesting wrinkle. The signal isn't identical in strength on both worlds. On Pluto, the absorption line is roughly 3 times thicker than on Titan, suggesting whatever this substance is, it's far more abundant on Pluto's surface. And on Titan, it's not evenly spread out either. The signal is noticeably stronger on the moon's trailing hemisphere, the side facing away from the direction Titan moves in its orbit around Saturn, than on the leading side. That kind of lopsided distribution usually means something about how the material forms or accumulates is tied to the local environment. Radiation, exposure, temperature, or some interaction with the surrounding space that varies by location. So what could it actually be? The researchers have a few candidates, though none confirmed. One possibility is benzene, a simple ring-shaped hydrocarbon, possibly combined with some other unidentified compound. Another is a form of acetylene or ketene ice, A third possibility researchers have floated is a class of molecules called alkenes. All of these are plausible in principle because both Titan and Pluto share atmospheres rich in methane and nitrogen, the raw ingredients for exactly this kind of complex carbon chemistry. Sunlight and radiation striking methane and nitrogen over billions of years can build increasingly complex organic molecules, the same general family of chemistry that produces the reddish-brown haze compounds called tholins found across the outer solar system. It's entirely plausible that this unidentified signal is some more exotic cousin of that same chemical family, something that forms under exactly the specific combination of cold, radiation, and methane-nitrogen chemistry that both of these worlds happen to share, despite being so different in almost every other way. But here's the honest scientific answer right now. Nobody knows for certain. A suspicion isn't an identification. Until researchers can reproduce this exact absorption feature in a laboratory, under conditions that mimic Titan's and Pluto's surfaces, the substance stays formally unassigned. A genuine open question sitting in the data, waiting for someone to solve it. And there's a reason this might not stay unsolved forever. NASA already has a mission built specifically to dig deeper into Titan's chemistry. It's called Dragonfly, a nuclear-powered, helicopter-style rotorcraft designed to actually fly through Titan's thick atmosphere and land at multiple sites across its surface, carrying its own onboard spectrometer, capable of directly sampling and analyzing the chemistry it finds. Dragonfly is scheduled to launch no earlier than 2028 and is expected to arrive at Titan and begin its mission around 2034. If this mystery molecule is still unidentified by then, Dragonfly could be the mission that finally puts a name to it. And depending on what it finds, that same identification could help settle the question for Pluto too, even without a matching mission there. Until then, this stays exactly what it is right now. Two radically different worlds, quietly sharing a chemical secret that no laboratory on Earth has been able to explain yet. Not proof of anything exotic, not evidence of anything beyond ordinary, if unusually persistent organic chemistry. Just a genuine, open mystery, sitting in freshly analyzed data from one of the most powerful telescopes humanity has ever built, in a part of the solar system we've barely begun to understand. That's honestly what makes stories like this worth paying attention to. Not because every unexplained signal turns into something dramatic, most of them don't, but because every so often, chasing one of these small, stubborn mysteries down is exactly how we end up rewriting what we thought we knew about the solar system in the first place. If you want to know what this molecule turns out to be when scientists finally pin it down, subscribe and turn on notifications, because we'll be covering it. Drop a comment with your best guess at what's causing this signal, and share this with someone who thinks we've already mapped out everything there is to know about our own solar system, because right now, in 2026, two worlds billions of miles apart are still keeping secrets we haven't figured out yet.